Hi guys, good evening. So in the last session, I believe we have covered about the ACLs, right? Now today we'll go with the redundancy protocols and translations. Now, what do you mean by redundancy? No. Redundancy means backup. Redundancy means backup. And the redundancy here we are talking about is the gateway level redundancy. Like who is your default gateway? Your router. If your router goes down, what happens? No communication. You don't have access to internet, right? So in companies, we cannot afford to have downtime. Okay. And this is where we use redundancy. Okay. So today we are going to talk about the FHRP protocol, stands for First of Redundancy Protocol. Okay. So FHRP is used to prevent your network failure at the default gateway. So that if your default gateway fails, you still have one more router to forward your traffic. Okay. This is achieved by configuring multiple routers with the same IP address and thus presenting an illusion of single virtual router to the host. What does it mean? You have more than one routers, but eventually on the client, only one gateway will be configured. So according to client doesn't know that one router is there or 10 routers are there. Client will have only one gateway. That means client will think, okay, only one router is there. Okay. And the IP address of the virtual router is configured on all hosts in that network or subnet as their default gateway. So whatever the virtual IP address will be configuring, that IP address will be giving it to the gateway. Okay. Now, if we talk about your FHRP, so under FHRP, we have three protocols, which is HSRP, VRRP, and GLBP. HSRP and GLBP both are Cisco proprietary protocols, okay, available in Cisco devices only. For open standard, we have Virtual Router Redundancy Protocol, VRR. Okay, so let's talk about few differences between your HSRP, VRRP, and GLBP. First of all, HSRP, it is Cisco proprietary. Your HSRP and VRRP, these are exactly the same only, not very much difference. And how do you configure them? Even then, that commands are almost same. It is Cisco proprietary, and here we have active and standby concept. That means if there are two routers, one will be active, another one will be standby. But if there are more than two, then other routers will be what? Candidate. Other all routers, they will be known as candidate routers. Okay. And here, what will happen? Active router will forward all the traffic. Your active router is going to forward what? The entire traffic. Then after, if active router goes down, standby will become, okay, your standby will become active and a new standby will be active. Okay. While if we talk about your VRRP, it is open standard. And here we don't have active and standby, we have master and backup. We have master and backup. So one router will be master and remaining all the routers will be backup. Okay. And here what will happen? Master router will forward all the traffic. Okay. If master is down, backup will become master. Okay. And GLBP, there is also Cisco proprietary protocol. And here we have active and active concept. There is no active and standby. All the routers will be active. Okay. So the terms that you will be using here is active virtual gateway. In short, AVG and active virtual forwarder. Okay. And all routers will be active. And they will forward. Okay. This is how it is going to be. Now, the thing is, in HSRP, let's say, see, if you want to understand gateway level redundancy, we will go with the HSRP. Although it is not there in the syllabus, but still we need to understand. Otherwise, like I said here, with this theory, you will not understand anything that how it happens and how it works. Okay. So let's go with the HSRP. In HSRP, what will happen? Consider here, this is the internet. Okay. And this is your network switch. And you have your PCs. Now you will be having a router for internet connectivity. And this is how it will be connected. Okay, consider here, this is the interface V 0 by 0. And here you have an IP and 111. And this is your PC1. And this is your PC2. Here you have used an IP address. And 1110. Here you have used 20. Okay. And this is your router R1. And this is R the internet. Okay, so in these PCs, what is the gateway IP address you will be using? Sorry, 1.1.1, right? And same thing you'll be using on this. Now, if this router goes down, okay, here, if this router goes down, that means your gateway is down. If your gateway is down, you won't have connectivity to the internet, right? You're not going to have any connectivity towards the internet. So if you will not have connectivity, that means your organization network is down. Clear? So we cannot afford this kind of situation in the organizations. And this is why we have redundancy. So how the redundancy will be there? We will use one more router. This is, let's say, another router. This will be connected here and will be connected here. And this one is R2. This is the 0 by 0 interface. And IP address 10.1.1.2. Now you have two routers. What is the gateway IP address you're going to set? Why not two? Hmm? Okay, let's say you have set 1.1.1. So if you are setting the gateway IP address as 1.1.1, your traffic will be passing like this. Now consider this is down. Now what? This communication is not possible now. Now what to do? How? System will not automatically go and select it. You have to manually give it. Okay. So let's consider what you did, that you changed the IP to 10.1.1.2. Okay, instead of 10.1.1.1, you gave the IP 10.1.1.2. Okay. You said that okay, this gateway is now not available. This is not available. This is not available. Okay. So what will happen? Your traffic will change. Your traffic will start passing this way. Correct. And meanwhile, your traffic is going via this way. Let's consider what you did. You troubleshooted this router also. And now this is working fine. Okay. But what if now this guy goes down? What to do again? Go back to 10.1.1. Again, you fix the R2, R1 went down. What to do? Every time change the gateway IP address. Right now, 2 PCs you can change also. Imagine a company where 5,000 systems are there. Morning to evening, you will keep on changing gateway only, right? Not a scalable solution. This is not a scalable solution. So even though you have two routers, okay, one more situation we can consider here. What is that? That I might do something like I will use in half of my network, I'll use 10.1.1.2, and in half of my network, I can use 10.1.1.1. But either of the router goes down, half of my network is down. Again, cannot afford to have downtime in my network. So here in this case, what we'll do is we are going to set a virtual IP that will be configured on both of these routers. They will decide who will forward the traffic, and that IP we will give here as a traffic. Okay. So let's see. So what I'm going to do here, I'm going to say that, okay, I'll configure a virtual IP here. And that virtual IP is going to be something like 10.1.1.254. Okay. And this virtual IP, we are going to configure on the client side interfaces here as well as here, because these are the client side interfaces. This side, the gateway has to act, right? So here I'll configure it. And this same IP address we will be using as a gateway here. So the same IP address, I'll configure it as a gateway. Here 10.1.1.254. Here also 10.1.1.254. Okay. Now once I configure it, these two routers, they will communicate with each other, R1 and R2. They will communicate with each other and they will decide that, okay, who is going to become active and who is going to become standby. Okay. So one of them will become active. And in case of HSRP, how they will decide the active? If I talk about active router active. So first of all, they will check the highest priority. Okay. And the default is 100. So first of all, they will check what? They will check about the highest IP address. Oh, sorry, highest priority. And second, if your priority is same, highest IP address. So between 10.1.1.1 and 10.1.1.2, which one is the higher IP address? 112. So that means this guy will become what? Active. And this guy will become standby. Once active and standby action is done, your clients will forward the traffic via active router. Okay, your traffic flow will be this. Okay, as soon as your active router is down, because they are continuously communicating via this link, so as soon as your active is down, automatically your standby will become active. Okay, this is down. So this guy will not remain in standby state. This guy will change it to active. Okay. This guy will change the state to active. Okay. And once this guy will change the state to active, your traffic flow will change. Your traffic will start going via this path. Now it will not go via this path. Okay. And let's say you fixed R2. If you fixed R2, then what will happen? That R2 will come up. And once R2 will come up, R2 will change its state to standby. It won't be active. Okay, automatically it won't be active. Okay. You can manually make it active, but automatically it is not going to go to active state. There is a feature that is known as preemption. Okay. In HSRP, we have a feature preemption. According to this preemption feature, high priority router will always be active. But by default, preemption is disabled in HSRP. That's why your high priority router will not become active, even if it is coming up again. Okay, so we can enable the preemption feature, and then your R2 will automatically become active. This is how it will be. Okay, but for that reason, you will have to configure priority here. So by default 100, so like on R2, you can configure 110, and you can enable preemption. Once you do that, then automatically it is going to go to active state, and this guy will automatically change back to standby state. This is how your HSRP is going to work. This is clear. Now let's see the configurational part. Only one line command is there, not a very big configuration. Understanding is important. Configuration wise, now all the concepts, they will have small configurations. Okay, like 1 line, 2 line, not bigger than that. Okay. So now let's see. Let's see the configurational part. So far, any doubt? Yeah. ACLs, did you practice? Good. So let's design the lab. This will be our internet. Then 2 routers I'll need, primary and secondary, standby backup. Okay, like that. This is our switch. And let's consider two pieces. Like 10110/22. This side we can use 11110/24. This side we'll use 110/24. And here I'll use a loop back e dot e dot e dot 8. This is our incoming. Okay, so from these pieces we will try to connect to the loop back. If we are having connectivity, that means we have internet access. Okay. So you can call it like primary ISP, secondary ISP, like that. Okay. So this side I'll use the IP 10112. This side I'll use 10111. Here I'll use 11111, 12112. Here I'll use 11110. And this side I'll use 12110. This is how the IP addresses are going to be. Clear? So the virtual IP that I'll be configuring here, same as our example, 10.1.1.254. Clear? Now, let's configure the PCs. So here I'll configure 10.1.1.10, 10.1.1.20. The gateway IP address will be 10.1.1.254, the virtual IP. PC one configuration done. Okay, before using this, let me use 10.1.1.1 only. Okay, initially we will check the basic connectivity. Okay. On all these three routers, I'll be using dynamic routing. If you want, you can go with the static also. I'll use dynamic for easier configuration. Okay. So let's say we will be configuring EIGRP this side. Okay. And AS number we will consider is 100. So this is R1, R2. Let me open master. Host name R1, 10111. No shutdown. This will be 11111 and router EIGRP 100. No auto summary. Network we will configure 10.1.1.0. Right. This is R1 configuration done. 0 by 0 will be, and this will be 12.1.1.2. This will be 12.1.1.2. Done. Then internet. This will be 11.1.1.10. 12.1.1.10. Then after here, it. Great. This is clear. Any doubt in the configuration? Yes, this is correct. It is not necessary that you give it in the sequence only. You can give in any sequence. Okay, like first 8 can come, then 12, then 11. That is not mandatory. Okay, sequence does not matter. Just the command should be there. Copy. Copy. Paste. Copy. So once this is done, now let me check connectivity with the internet. So first packet will drop due to app, and we have communication, right? Now, right now my gateway is this guy, R1. So if this goes down, okay, write the configuration and just power it off. Now, if this guy goes down, I'll not have any connectivity. I'm not going to have connectivity. Why? Because my gateway is down. And even though I have second router, so if I will change the IP, I will have communication. But again, if the second router is down, I'll have to change the gateway again, right? So rather than going with this thing, we will go with the HSRP configuration, that how you can configure HSRP. Okay. So let's bring it up again. Now let's say this is R2. So what is my client side interface? Z0 by 0. Okay, so I'll go to that interface. Interface give 0/0. I'll give the command standby. Then you have to give a group number. Spelling mistake. Standby. Then you have to give a group number. Okay, so total 4096 groups can be there. You can use any group number. I'll use one. Okay. Then I will give the keyword IP, and the keyword IP will do what? It will enable HSRP, and then I can set the virtual IP address. So I'll say standby 1 IP, and what is the virtual IP I want to set? 10.1.1.2.3.4. Same one line command, you go and give it in the R1 also. See here. Interface gig 0/0, standby 1 IP, 10.1.1.2. Same command, no need to change anything. Now what will happen? These two routers, they will communicate with each other. This guy already became active. Became standby. Now here you can come and check. Command is show standby, and here you have to use a 2. So you can see the current state of this guy is what? Standby. This is the virtual IP address. When you set a virtual IP address, automatically a virtual MAC address will also be assigned. Then who is the active router? 10.1.1.2. Standby router is local. That means itself is standby, and priority by default is 100. Okay. Sorry. Hmm. By default, it is 100. We can change it. Okay, here the same thing. You can see I can use the keyword commands standby 1. Instead of IP, I can say priority. And I can set the priority also. Anything between 0 and 256. So that is up to us. Okay. Now by default, you can see preemption is also disabled. Okay, so let me write the configuration here. In the R2, which is our active router, you can check to show standby. So this guy is active right now. So now if this guy will go down, and before that, let's check the communication. Okay, right now if you will see, I'm having communication. Okay, and if I try to trace route, going where? 10.1.1.1, right, which is R1. Now, wait a minute, why R1? This is the bug. It's not going R1. So R1 is standby. Active router will forward the traffic. Okay. So there is a problem with this. Let's check it through the packet capture. Packet tracer, sometimes it will show you bug. From here to, but I cannot mention IP here. Let's see. Still active router will forward the traffic. Very strange. This is a bug. Okay. This is definitely a bug. Your active router will forward the traffic, which is R2 right now in our case. Here we can see R2 is what? Active. Okay. So even if your active router will go down, you'll see, like if this guy goes down, now this is off, and this guy will automatically change the state to active. You see? Now if I say do show standby, okay. So state is active right now and standby router is unknown. Why? Because this guy is not up. You don't know who is standby. Once this guy will come up, then this guy should remain in standby. Okay. Why? Because preemption is disabled. Again above here. Okay. Okay. This is again a bug. Yeah. Because preemption is disabled and this should not automatically become active. Okay. One time a router is selected active, it will remain an active until or unless you manually make it standby. Okay. And if your high priority router goes down and preemption is disabled, so again it will not become active automatically. Okay. So the same thing here. Here this is a column with the packet router only. So standby. So now this guy is active. Okay, but it should not happen. So if you want to enable preemption, in that case, how you will enable it? Yeah, this is packet with a problem. You will say standby one preempt. This is the command to enable preemption. Okay. No, no, only on the high priority router. On the high priority router. So like this guy here. If I say interface gig 0/0 standby one IP. Okay, IP we have already configured. Priority 110. So by default, this guy has 100. I'm increasing the priority here. Okay. By mistake, I enable preemption here. This should not be enabled. Okay. So on high priority router, you will enable the preemption. So right now you can see this guy is active. But as soon as I will enable preemption, change state to active. Okay. And this guy will go to standby. Now here, write the configuration to show standby. So you can see this is active because high priority. And this time preemption is enabled. So now if I power off this device and power it on again. Okay, so right now this is down. This should change the state to active. See? So right now this guy is active here, active. But this time this guy is having high priority. So automatically this should become active. Okay, active. So standby. This guy is active and this guy has changed the state to standby. This is how your preemption works. Clear? So this is how you can configure HSRP. Okay, what we can do is we can decide that okay, one router will forward all the traffic. One router will forward all the traffic. If your active router is down, in that case, your backup router or your standby router is going to forward all the traffic. Okay. So now it is clear that how you can have gateway level redundancy. We don't have to check we don't have to go and change anything in the PCs. Okay. In the PCs, we don't have to go and change anything. We will have communication. This is way you can see the communication here. I will have the communication. Clear? This was about your HSRP protocol. Now, next thing is about what? Translation. What is translation? Translation simply means what? That you are translating one form to another. Okay. So here in the IT and networking, we talk about network address translation. Okay. In short, we call it as a NAT. Okay. Now, as per Cisco, we have two types. Okay. We have NAT and we have PAT. Okay, so in the NAT, we have static NAT and dynamic NAT. Network address translation, port address translation. And same thing we have in the PAT also. Dynamic PAT and static PAT. Okay. So this is how it is in case of Cisco. And when it comes to other vendors, it is we have source NAT and destination NAT. We have source NAT and destination NAT. Now, what is source NAT? So technology is the same. Okay, just the terms are different. So under source NAT, your these categories will fall. Okay, these categories will fall under source NAT, and this one is destination NAT. This will fall under this category. Okay. Now in our CCNA, you will be studying about this as per CCNA. The source NAT you will be studying. But once you will come into the CCIE, there I will explain you about static NAT. I'll explain about dynamic NAT. And then I'll explain about dynamic PAT. Then static PAT. Then about destination NAT. Then about auto NAT. Then manual NAT. Policy NAT. Zero NAT. identity NAT, voice NAT, these transcriptions. Yeah, everything from see whatever you study in your NA and NP, we say forget it. When you come into the CCI, we say forget that. We start from scratch again, and then we go till all these different types of NAT. Okay. So this is what you'll study in your CCI. This is clear. Now let's talk about the differences between your static, dynamic, and dynamic NAT and static. Okay. So first of all, your static NAT. Static means what? Fixed. First of all, in static NAT, so how would you define your translations? How would you say what is NAT? Okay. So NAT is used to translate your one IP address to another IP address. To translate. Okay. And mostly it is used to translate private IP to public IP and vice versa. Mostly your NAT is used to translate private IP to public IP and vice versa. See, initially what happens that your public IPv4 addresses, they are limited. Limited number of addresses are there. So in the 1990s, your internet community, they already knew that the addresses will not be sufficient. So they started working on the solutions and they came up with what? IPv6, right? Now IPv6 has huge number of address, unlimited number of address, right? But the thing is that suddenly your companies, they were not ready to switch to IPv6. Imagine you have been working for years on IPv4 and suddenly you have to start your network on IPv6. Not easy. And IPv6 technology, it was new. People needed time to adapt it. So during that time, what to do? Because companies, some companies will adapt, some companies will not adapt. And to some companies, it will take time out. So it was not possible all at once. So the internet community came up with a solution, NAT. That okay, no problem. So what do? You use NAT. With the help of NAT, we started using the private IP addresses. Otherwise, before that, we were not using them. Okay, the private IP addresses, we started using them. And what happened? That hundreds and thousands of PCs, they were getting translated to a public IP and they were able to use the internet so that they can get some time to adapt to IPv6. But what happened? People started seeing the benefits of the NAT. And till date, even today, IPv4 is being used, even after 35 years. Okay. So this is because of the benefits of NAT. Okay. Now let's say, for example, in my private network, I'm using IP 192.168 or any IP. Let me check what is the IP I'm getting right now. So if I check here right now, if I say IP config, so you can see what is the IP I'm getting here. 192.168.0.178, and this is a public or private? No idea. I have explained, right? Private IP range. Yes, this is private only. Private only, right? Yes. So this is private IP, but when I'm going to the internet, I'm not using this IP. Okay. When I'm going on the internet, I'm not using this IP address. So if I go and check what is my IP address, you can see this is my public IP address. So when I'm going on the internet, I'm using this IP address, and when I'm using my local network, I'm having communication in my local network, then I'm using the private IP address. Okay, so who is translating? Because when my IP is going outside, somebody is translating my IP address, and who is that? Your router, your gateway, your router. Okay, so your router is responsible for doing these translations. Okay, now let's come to the static, dynamic, and different kinds. So first of all, we have static NAT. Okay. Now in static NAT, what happens that for every single private IP address, you need one public IP address. Okay. So here it is what 1-to-1 mapping. 1-to-1 mapping means what? Is translated to a fixed public IP. Okay. That means for every single private IP, you need one public IP. So if you have 1,000 systems in your network who wants to access the internet, how many public IP you need? 1,000, right? So as the number of public IP addresses, or let me explain it like this. NAT. In static NAT, if 1,000 systems wants to access internet, 1,000 public IP addresses are required. Okay. Right? Which is costly. Private IP addresses, sorry, public IP addresses are not cheap. Okay. So this is costly. So in organizations, we do not use static NAT for clients. Okay. This is generally used for service. Okay. Example, web server. So whenever you want to access a web server remotely, you need a public IP address, and you don't want that the IP address of the server should change. Otherwise, you will not be able to access it. So there you use static NAT. Okay, we do not use it for client. Now in static NAT, we came to know that okay, it is 1-to-1 mapping and it is fixed, right? So that means here the mapping will be done what? Manually, like static routing, right? Same thing. We had to manually configure it, and here the mapping is done manually. That means the admin has to map every single private IP with the public IP. Okay. So the admin doesn't have to map. So for this reason, what was done? New NAT was introduced, which was dynamic NAT. Or you can consider dynamic routing, where networks were automatically getting discovered and all those things. Here mapping will be done automatically. Okay. So even dynamic NAT, it is exactly similar to your static NAT only. Only difference, mapping will be automatic. Okay. So this is also 1-to-1 mapping will be there. Okay. This is also 1-to-1 mapping. But here what will happen again? Here you will require a range of IP addresses because more than one IP address is there. In static 1-to-1. Okay. So that means for every single IP, admin will decide that okay, this will be the public IP. But in dynamic, if it is automatic, that means anything can be. Anybody coming first will get the first IP. So here I say here a number of private IP addresses are transferred to a pool of public IP address. Pool means range of public IP address. Pool simply means what? Range. Okay, and the mapping will be done automatically. Okay, and again in this case, this statement still remains true because it is also one-to-one mapping. So if 1,000 systems wants to access internet, then again you need 1,000 IP addresses and it will be costly. Okay. Only difference is what? That your mapping is being done automatically. Okay, mapping will be on the basis of first come, first serve. Okay. Now, still, if I need to purchase that those many IP addresses, this is very expensive for the organization, right? So finally, we came up with the concept of PAT, port address translation. In PAT, what happens? A number of private IP addresses are mapped to a single public IP address. Okay. And when I say a number, so approx 64,000 addresses can be mapped with a single public IP address. Okay. And this is being widely used in the networks, in our home networks, in Soho architectures, in the companies also, it is highly being used. Because companies, they don't have to purchase multiple IP addresses, they can purchase one single IP and they're good to go. Okay. So here the mapping will be done automatically. Okay, the mapping will be done automatically. And the thing is that here, if you consider, let's say this is my router, okay, and this side I have internet, this side I have a server. On this side I have my local network in which I have PC1 and I have PC2. This PC is having 10.1.1.1. This PC is having 10.1.1.2. Here it is 10.1.1.10. And let's say I have purchased few IP addresses, or here in this case, I'm saying that, okay, single IP address is required. So let's say I have purchased one IP that 200.1.1.1. Okay. So what will happen whenever this guy will go outside? His IP will be translated to 200.1.1.1, and whenever this guy will go outside, again this IP will be translated to 200.1.1.1. So consider your PC1 generates a traffic. PC1 says that source IP 10.1.1.1, destination IP, let's say this is 11.1.1.100. 11.1.1.100. Okay, this way he will send the packet. Once the packet will come on the router, router will change it. Router will say source IP 200.1.1.1. Destination IP 11.1.1.100. Correct. Same way, when this guy will generate the traffic, this guy will say source IP 10.1.1.2 and destination IP 11.1.1.100. When this message will come to the router, router will translate it. Destination IP. And what your router is going to do, your router is going to make a marking in the table. Router is going to say that, okay, I have translated 10.1.1.1 into 200.1.1.1. And I have also translated 10.1.1.2 into 200.1.1.2. Sorry, not 1.1.2, it is 1.1.1. Okay. Now what will happen when this server will respond to this message? Server will see source IP 200 dot, sorry, 11.1.1.100. Let me change the color. So when this server will respond, right, server will say source IP 11.1.1.100, destination IP 200.1.1.1. And when it will respond to this one, source IP 11.1.1.100 and destination IP 200.1.1.1. These two messages will come to the router. The router will see who is the destination, 200.1.1.1. Now, how router will decide that, okay, which traffic belongs to which PC? Because when router will check, okay, 200.1.1.1, 10.1.1.1, 200.1.1.1, 10.1.1.2. So how router will decide whether this message is for PC1 or this message is for PC1, right? And this is where the role of your port numbers will come. Because these guys, they will also mention the source port and destination port. So let's say this guy is accessing HTTP. So source port, let's say he is using 123. Okay. And same thing here also, let's say this guy using source port 123 and destination port 80. So what router will do, when router will mention about the IP address, router will say that, okay, this guy came with port number 123. This guy also came with port number 123. They can come with the same port number, different port number. It completely depends, but doesn't matter. How? What router will do if they are using same port numbers? Your router will say that, okay, for 10.1.1.1, I will translate it to port number 123. And for this guy, I will translate it to 11.1.2.2.3. Not IP addresses, because according to IP address, it will get confused. So it will check, okay, that source port is here 80 and destination port will be, let's say, 11.1.2.2.3. Okay, I think this is too much. Yeah, port numbers will go more. So let's say it's something like this. Okay, and when the reply will come for this message, so it will have source port 80 and destination port 123. Now, when these messages will come, your router will check that, okay, it is coming to 200.1.1.1 port number 123, 200.1.1.1 port number 123. That means forward here. Response coming to 200.1.1.1 port number 11.1.2.3. This one, so going for 10.1.1.2. This is how, based on the port numbers, your router will segregate the traffic. And since we have 65,536 ports, out of that, we know that, okay, 0 to 1023 are what? Well-known ports. So let's remove these ports. Still, we will have approx 64,000 ports. And this is why we say this thing, that approx 64,000 addresses you can map with single public IP address, and router will segregate the traffic without any problem. This is how it will happen. Clear? Okay. So here we can say the traffic will be segregated based on port number. The traffic will be segregated based on port number. Now let's talk about the syntax of your NAT, how you will be configuring NAT. First of all, static NAT. If you want to configure static NAT, see, you will have to look at the traffic flow and you have to decide which is your LAN interface and WAN interface. LAN will be inside, WAN will be outside. Okay. So the first thing you will do is what? You will define inside and outside interface. Okay. So how you will define it? You will just go to the interface name, and you will give the command IP NAT inside. Okay. Then after for outside interface, same thing you will repeat. You will say here IP NAT out. Once you define inside and outside interface, now you can configure NAT. Configure static NAT. How will you configure it? You will say IP NAT inside source. And since you are configuring static NAT, you will say static. Then you will give your private IP address, that which private IP address you want to translate. And then after you will give your public IP address. Okay. This is how you will configure your static NAT. In dynamic NAT, what will happen? You will use a pool of public IP addresses. You will need a range of IP addresses. Okay, so first thing again in the dynamic NAT also, whatever you'll do is you will define your interfaces. Once you define the interface, then after, see, if you have more than one network, you might have more than one network in your local area network. So for which network you want to do the translation, you will have to filter out. And for filtering the traffic, what we do, we use access controllers. Okay, so here what I'll say is create ACL to select the traffic, that for which traffic you want to do the translation. And here you can use standard access list only. So you can say access list and you can use a number between 1 to 99. Then we can use whether we want to permit or deny. Then you can say here network ID. Okay. And you can say what wildcard marks. Once it is selected, now next thing you will do is what? You will create a pool of public IP address. Then you will say IP NAT pool and you will give a name to the pool. Any name you can give as per your choice. Then what is the starting public IP address? Okay, then you will give the ending public IP address. Then you will use the keyword net mask. And here you will give the subnet mask. Once this is done, then you can configure what? Dynamic NAT. How you will configure the dynamic NAT? You'll say IP NAT inside. So now this time it is not static. Okay. And earlier, if you see here, I said first of all private IP, then public IP. So in this case, my private IP will be available in the ACL and my public IP addresses are available in the pool. So I will say that I want to translate my list number. So here I'll give what? ACL number. That this is the list I want to translate and where? In the pool and whatever is the pool name you have configured. Same thing, private first, then public. And this is your dynamic NAT configuration done. Okay. Then after in the PAT, so PAT configuration is kind of similar to your NAT, only if you use one extra word here, overload, it will become PAT. Okay, one single change you can do. Okay. So first of all, let me show you, configuration for your dynamic NAT and static NAT and dynamic NAT practically. Then we will move on towards PAT. Okay. So let me go and configure it. Simple. We'll keep the topology simple and small. So I'll use one router, and then I'll use two PCs. Two will not be sufficient. And I'll use one PC here. This is one PC for which I'll do the static NAT. For this guy, I'll do the static. And for these, I'll go with the dynamic. Okay. And this guy will connect here. And this will be a NAT router. On this side, I'll use the network 192.168.10.0/24. On this side, I'll use 192.168.20.0/24. This side, it is internet PC. Okay. So let's say this side will use 11.110/24. Okay. So this will be 11.11100, 11.111, 192.168.1.1, 10.1. On this side, it will be 20.1. And this will be 20.20. And this will be 10.10. And this will be 20.30. 20.40. This is clear. Let's go and configure it. Ten dot 10.1. 20.20, 20.20. 20.30, 20.1, 20.40, down 1, router configuration, interface, gateway/0, IP address, that will be done. Now, first of all, static NAT. Okay, so initially you can check whether I have communication with the internet or not. And same thing we can check from here also. From all the PCs we will check. You see? Everybody has the communication. And even this PC also has. So right now they are communicating, and if you check whether there is any translation or not. So first thing first, you can check on the router itself. Okay, the command is show IP NAT translation. Okay, and you can use a do here, and you say there is no output because there is no translation right now. Now let's say what I'll do is I'll configure static NAT, and I'm saying that for this guy, I will purchase one static IP, which is 100.1.1.10. Okay, this guy should be translated to 100.1.1.10. This is what my requirement is. So what I'll do, I'll just go here on the router and I'll start configuring. So if I look at my traffic flow is what? This. So which interface is inside and which interface is outside? Correct. And 0 by 2 is outside. The same thing I'll configure here. Interface is 0 by 0. IP NAT inside. Okay. Now let's configure the NAT. So I'll say IP NAT inside to static. And what is my private IP? 10.10 and public IP is 100.1.10. And this is my NAT configured. Okay, once your static NAT is configured, now check do show IP NAT translation. Now you can find the translation that this IP will be transferred to this IP. Okay, so now if I try to communicate, so I will still have a communication. Let's say this one. I'm having the communication. And if you look here in the simulation mode, if I capture ICMP, and if I generate the traffic, so initially here you will see PC is not aware of the translation. So here the source IP is 10.10 only. When it will come on the router will do the translation. So the packet that was incoming to the router was having 192.160, 10.10 as the source, and here you can see after translation it is 100, 11, 10. This is what your translation is happening. And this is how my system right now, it is going on the internet and having the communication. Is that clear? So this is how you can configure static net. Now what will happen? What is the benefit I was talking about? Nobody can know your private IP because on the internet only public IP is traveling. So nobody will come to know your actual IP address. That means you become secure. This is one of the benefit of NAT we are having. Okay. This is clear. Static NAT. Now let's say I want to do the dynamic NAT configuration. So if I want to do the dynamic NAT configuration, in that case, my traffic flow will change. In that case, my traffic flow will be this. So which interface will be inside, which will be outside? 0 by 1 is inside, 0 by 2 is outside, right? Okay. And let's consider that, okay, for this network, to translate this network, what I'll do is I'll purchase few IPs from the service provider. And I'll say I will purchase the IP addresses from 150.11 to 150.11.20. 10 IP addresses I have purchased from the service provider. Okay. Now what? This is my private network. I will configure it in the access list. This is my pool. Okay. Let's go and do it. So interface. This will be inside interface big 0/2 IP NAT outside. Then after, first of all, let's configure the access list. Permit 20.0/24, not slash, I mean wildcard we have to give. Then configure the pool. Starting IP address 150.1.1.11, ending IP address 20. Give the net mask here, which is this. Now what? Configure the dynamic NAT IP NAT inside source. Configure translate the list number 1 into the pool PCM. This is your dynamic NAT configuration done. Now if you check the translations, so right now you'll not find an entry. Why? Like I said, the mapping will be done automatically. So if somebody will come, then only translation will happen. Okay. So right now what I'll do is I'll generate the traffic. So PC1 will go with the static only. These 2, 3, and 4 will generate dynamic NAT traffic. This is PC2, PC3, and PC4. Done. Now let's go and check on the router about the translations. So you can see my IP address .20.20 was translated to 150.1.1.11. 30 was translated to 12. 40 was translated to 13. So it is packet tracer. That's why these translation you are seeing in sequence 11, 12, 13. But if it is a real device, it will be completely random. It can pick up any IP address from the pool. Okay, this is how the translation happens in the dynamic. Clear? Any doubt? No? Online people? Now, next thing is about port address translation. So for port address translation also, we will use this network only because multiple systems we require. So again, Z0 by 1 will be our inside, Z0 by 2 will be
sir.
outside. Okay. Yes, any doubt? Okay, so Z0 by 1 will be again inside and Z0 by 2 will be outside. Now the thing is, PAT configuration we can do in two ways. One is I can purchase a specific IP address and to that IP I can translate, or else what I can do like we use in our home networks. We don't purchase the IP, but still we are able to use internet. How? We are translating everything to the outside interface IP address. Whatever the IP address my ISP has given on my router, that IP address I will translate. Okay. So these are the two possibilities. So let's go with this. So first case, using a static IP address to translate. Okay, if you are using a static IP address, in that scenario, you have to define inside and outside interface, and you will have to select the network. Right now, also we are having two networks. Out of them, I want to use 20 network for translation. So what I'll do is I'll use the same thing. This is the same thing we'll use here. Okay. And here in the pool, what I did, I used starting and ending. But if I use only one single IP address in the pool, there will be no other IP address left. In dynamic NAT, what happens? If you have 10 IP addresses in the pool, so only 10 PCs will be able to access the internet. PC number 11 will not be able to access internet because you don't have a free public IP address. Okay. So here, if I want to translate everything to a single IP, I will use only one single IP here. I will create a pool, but here starting and ending, no, only private IP address I will use. One single private IP. Okay. So I'll say configure tool for single public IP address. Okay. And how you will configure it? You will say IP NAT pool. Again, you will give the name of the pool. Okay. After the name, you will give the private IP, sorry, not private, public IP address. In the pool, public IP address. Again, you will give the public IP address. That means my ending IP and starting IP is the same in the pool. Okay. Also net mask, and I'll give the subnet mask here. Okay, because I have only one IP, so I'm using same thing here. Starting also same, ending also same. Once this is done, then I will configure the configure path. So you'll say IP NAT inside source, and I want to translate my list number one, whatever is the ACL number, into the pool name. Okay, but again I said if in the pool only one IP is there, that means only one address will be able to use the internet. Second system will not be able to use the internet. I want to reuse the same address again and again. So I'll say overload this IP. Overload the same and same IP. So it will keep on using the same IP. And this will become path. This is the first case. Second case, when you are using outside interface IP address, whatever the IP address your service provider is assigned you on the public. Okay. So that IP address also you can use. How you're going to use that? Using outside interface IP address. This is what we generally use in the home networks. Okay. And is being highly used in the organization also because they don't have to purchase IP here. So again, in this case, you will require inside outside definition. Okay, you will have to define inside and outside. You will have to select the network. But this time we don't need the pool. Okay, pool will not be required. So these two things, again, these will be seen. No, we don't need to mention. Mapping is automatic, right? So dynamic, it will happen. Directly you can configure pool. I mean, not pool, path. Configure path. How you will configure it? So you'll say IP NAT inside source, and you will say, I want to translate my list number, whatever is the ACL number. After that, earlier we gave the pool name here, but this time we don't even have a pool. So what I'll say, translate it to the interface, and here you will give what? Outside interface name. That translate it to this IP. But again, this is again a single IP, so we will overload this again. So we'll use the word overload. And this is your second type configuration. Okay. So let's see practically. Let me remove the NAT configurations. Let's see, no to the pool also. And for access list also, I'll say no. Okay. Dynamic NAT configuration is removed. You can check to show IP NAT translation. There is no translation. Okay. And dynamic NAT translation entries, they will also wipe out with time automatically, because continuously continuously translations has to be done. So the old entries has to be removed. Okay. So how can you check whether you have configuration or not? You can check your running configuration section NAT I'm looking for. So you can see only static NAT configuration I have. I don't have the dynamic NAT configuration. Now let's do the configuration for the port address translation. And this time I'm considering that, okay, for port address translation purpose, I have purchased one single IP 200.111. Okay. So I'll say interface V0/1. Although this interface is also already configured inside and outside, you don't need to configure again and again. But I'm showing you as per fresh configuration. So I'll say interface V0/1, and then I'll say IP NAT inside. Interface V0/2, IP NAT outside. Then I'll say access plus one permit. Select the network. Then after you say IP NAT to CCNA. Starting IP address, let's say 200.111. Ending IP address 200.111, because single IP address. Then I'll say net mask, same net mask I use. Then I'll configure the path. So I'll say IP NAT inside. So translate my list number one. My ACL number is one. So I'll say translate my list number one. And to what you have to translate the pool? TCNA. And I want to overload the IP. Done. Now, right now, if I check do show IP NAT translation, so I'll not find anything again. Automatic mapping means when traffic will generate, then only mapping will be done. So let's go and generate the traffic. Here also traffic is getting generated. And here also traffic is getting generated. Now go and check on the router. Do show IP NAT translation. You can see all the IPs .20 translated to 1, .30 translated to 1, .40 also got translated to 1. And here you can see that this 20 IP with port number 11 has been translated to 200.111 port number 11. Same way 40 IP with port number 11, change the port number. So that when the reply will come to this port number, your router will know that, okay, it has to send to this IP and this port number. Same way 30 IP. This is how based on the port numbers, the traffic will be segregated. Clear? Okay. So this is how you'll do the configuration for what? You will do the configuration for static IP. Now, how will you use the interface IP? Okay. So what is the IP on my outside interface? 11.1.1. So this time, whatever the translation we will do, that is going to use 11.1.1. Okay. So let me remove this configuration. This is removed. Pool is also removed. And let me remove the access list also. Done. You can check to show run, and I want to check the section. No configuration. Only static net configuration is there. Again, inside interface v0/1. This will be inside interface v0/2. IP net outside. Now create the access list. Permit 20.0 255. Now this time no need to create a pool because I want to use the outside interface IP. So how I'll say IP net inside store, and I want to translate my list number 1 into the interface. Now what is my interface name? So my outside interface is Z0/2. So I want to use the Z0/2 interface IP address, and I want to overload the same IP address. Okay, do show IP net translation. Right now, no translation because dynamic. Generate the traffic, and there will be entries. And now let's go and check here. Do show IP net translation. You can see everybody got translated to 11.1.1. This is how it works. 20 to 1, 30 to 1, 40 also to 1. This is how your translations are working. Clear? Online people? So this is what is being used the most as of now. Okay. Because you don't have to purchase IP, or ISP is giving you the IP already. Okay. So that this is it for the day. We have discussed about redundancy protocols and we have seen translations. Even that is not there in the syllabus. No, you only have that what is the purpose of using FHRP, not even HSRP. What is the purpose of using FHRP in the networks? So to say in one line, gateway level redundancy, and that's done. Let me show. CCNA is like very basic. Okay. In the day one itself, I have explained that, okay, you're going to have only fundamentals here. All the configurational and detailed part, that is for the NP. So if you see here, this is only there. Even HSRP, VRRP, nothing is there. But if you want to configure VRRP, see, for HSRP, the command was standby. Okay, like we use the command something like, for HSRP, I use the command standby 1 IP, and then I configured 10.1.1 to 54. The change in VRRP will be what? In place of the keyword standby, you will use the word VRRP. Only that difference is there. Other than this, what is the difference? In HSRP, your preemption is disabled by default. In VRRP, it is enabled by default. Remaining everything is same. Priority and all the concepts. Official Cisco syllabus. This is what I have told you is official Cisco syllabus. Yeah. This is officially from the Cisco itself. And if you want to verify, even you can do that. See here. Cisco CCM. Exam details. Give you exam topics. So in the IP connectivity, it is the same thing. So CCN is all about fundamentals only. Okay. Yeah. How many sessions still remaining? So we might complete it by next week. Yeah. So approx whatever the 9 to 10 sessions are there. This is how it is. I checked in the Cisco website that season course is going to change after 19th of August 2024. So I'm planning to give exams in September. So do you explain which module?
We're going to added in this CCN exam version 1.1.
So version 1.1 will be live. It will take time, I think. Okay.
But in the Cisco website, it's mentioned that after 19th of August, there will be new syllabus will be applied on
Yeah,
the
then they
exam.
will release the new syllabus, right?
Yeah,
Yeah. So in the new syllabus, AI and machine learning concepts are added.
yeah. So if I'm going to apply in September, so
I don't think you should
do I
do
need to
that.
prepare for that module, right?
You should wait for it. Okay. Immediately going for the new version is not a good idea.
Okay,
Yeah.
but what if it's added in September's exams?
No, no, no.
Then you
See
will.
here, if you see on the Cisco website, it is not like this. Okay. Other than this, in the today's part, any doubt? No? Okay, then let's stop the recording for a while.